Section 3.1, quadratic functions. We're going to define and graph quadratic functions. The graph of the quadratic function f of x is equal to ax squared plus bx plus c equals 0, where a is not equal to 0 is the set of points x comma y that satisfies the equation y is equal to ax squared plus bx plus c. Parabolas. Here's some pictures of parabolas. And on yours, you might want to put arrows because it goes up and down forever. Those are what parabolas look like. The axis of symmetry is if I folded along the axis, the two halves would coincide or they would be symmetric. The equation for axis of symmetry will be x equals some number, and I'll give you that equation in a minute. The vertex is a point in the parabola where the axis of symmetry intersects the parabola. So here's my axis of symmetry, intersects the parabola. That's the vertex. Axis of symmetry intersects the parabola. That's my vertex. As the absolute value of this a, the coefficient of x squared, gets large, the parabola gets very, very narrow. As the absolute value of a gets smaller, like fraction 1 over 10 or something, it'll become wide. If a is positive, it'll open upward. If a is negative, it'll open downward. The y-intercept of the parabola, y is equal to ax squared plus bx plus c is. Remember, y-intercept is where it crosses the y-axis. It's where it crosses this axis. Not this axis, but this axis, the y-axis. Everything that crosses the y-axis has the x-coordinate of 0. So if I put in an x equals 0 and an x equals 0 there, I'll get C. The x-intercept of the parabola, so where it crosses the x-axis, we know that the y has to be equal to 0. So then you would set y equal to 0. And there, to solve it, you would factor quadratic formula, completing the square. We've done all that in a previous chapter. If the discriminant, remember this was under the radical, that's the discriminant. It was under the radical of the quadratic formula. If that discriminant is greater than 0, there will be 2 intercepts. Sort of like this one, 2 intercepts. If the discriminant is equal to 0, it'll be tangent, 1 intercept. It'll just touch. If it's less than 0, there'll be no intercepts. No x-intercepts whatsoever. And here's where I told you I would tell you the equation for axis of symmetry. X is equal to the negative of b over 2a. And if I want to find the vertex, after I find out what this number is, I plug it into the equation for x to get my y. Okay, so the vertex is an x comma y. So I plug in that x to get my y. So sketch the parabola, 2x squared minus 8x plus 5. Label the intercepts, axis of symmetry, and the vertex. So let me see if I typed any of it out. I don't remember if I did. No, I didn't. So I'll write it all out. Label the intercepts. Okay, so let me do that. X-intercept, y-intercept. Remember the y-intercept, x is equal to 0. The x-intercept, y is equal to 0. So let's do the y-intercept first. That's easy. The y-intercept, when x is equal to 0, you get 5. The x-intercept. Your y is equal to 0. Okay? So when you're doing that one, first of all, I'd look at it. Can I factor it? And when you look at it, it looks like it will not factor. So we'll either complete the square or quadratic formula. I think I will do quadratic formula. The opposite of b, plus or minus the square root of b squared minus 4ac all over 2 A. So I have 8 plus or minus the square root of 64 minus, this is 4 times 2 times 5. 5 times 2 is 10 times 4 is 40. Over 4. Keep going. I have 8 plus or minus the square root of 64 minus 40 is 24 over 4. Let me keep going. 24, remember 24 is 2 times 2 is 4 times 6. So I can rewrite it as 8 plus or minus 2 radical 6 over 4. Reduce it. If I factor out a 2 and then cancel it out, I'll have 4 plus or minus radical 6. Okay? On a test, I'll give you nicer numbers than this. So what you would do to find the intercepts is you would pick up your calculator. So let me pick up my calculator here. And let me put the number in my calculator and see what I get. Let me see what I get here. Okay. You hide it. Okay, so I had 4 plus or minus 6 over 2. Oops, second, quit. So I have a fraction. So I'm going to use the fraction key because I think it's much easier. 4 plus square root of 6 over 2 gives you about 3.2. So you get 3.2. And I am going to just come, instead of retype the whole equation, pull the same equation. And now go to my equation. Change that to a minus. And you get about 0.78. Okay? So let me graph those now in my graph. I have my Y-intercept of 5. 1, 2, 3, 4, 5. I have my X-intercepts of 0.78, which might be about there, and 3.2, 1, 2, 3.2, which might be right about there. Okay? So there are my intercepts. My axis of symmetry, remember, X is equal to the opposite of B over 2A. So the opposite of B is 8 over 2A is 2. 8 over 4 is 2. So the axis is symmetry. And you can double check. Did I make a mistake? Well, it's symmetrical with that. That's about the same distance. So no, I'm sure I didn't make a mistake there. So you can do some double check, make sure it makes some sense there. Also, now if I know that point there is 2 over from the axis of symmetry, I know that there's a point right there because it's symmetrical. Okay? So my axis of symmetry, if I ask you what the axis of symmetry on the test is and you tell me 2, I will tell you you are wrong because the axis of symmetry is the equation x is equal to 2. So that's what you would write. And my vertex, plug in x equals 2 into my original equation. So I'm in green now. And so my equation is 2. X was 2, so 2 squared minus 8 times 2 plus 5. 2 times 2 is 4, times 2 is 8, minus 16 plus 5. 8 plus 5 is 13, minus 16 is negative 3. So my vertex then is 2 comma negative 3. So now I have some points, graph it. So now it looks something like this. There's my parabola. If the equation of the parabola is written in the form y is equal to a times the quantity x minus h squared plus k, then the vertex is hk. So the vertex of this will be HK, 3, 7. The vertex of this one would be -9, because it's not in the right format. You have to do minus a -9, like I did here. 2. -9, 2. Okay, so if it's in that format, easy to do. So I want to find the vertex of the parabola. Y is equal to -2x squared plus 12x plus 4 by completing the square. Find the x and y intercepts. So the first thing I did is I took my equation. And since I don't have an equal 0 like I did in that last chapter we did, I have just y. I don't move this to the other side, I just move it away. So I move it outside. So I took this part of the equation. To complete the square, you need the coefficient to be 1, not a -2. So I factored out a -2, and when I factored out a -2 from here, I got x squared. When I factored out a -2 from here, I got a -6x. Now complete the square. Half of -6 is -3 squared. -3 squared is 9, times a -2 is -18. So I just added -18 to this side. So what I do to one side, I have to do to the other side, -18. And then I'm going to move it over, plus 18. Okay? Here's my -3 squared. So if you want to write it that way, you can, but -6 divided by 2. Now, to complete the square, I have my -2. That without the squared is x. This without the squared is -3. Quantity squared plus 4 plus 18 is 22. Now I can tell you easily that the vertex is 3, 22. Okay? Done. Y is equal to, oh, this was the same thing. Now, oh, I wanted to graph it, didn't I? Did I say graph it after that? Oh, I'm sorry. Find the x and y intercepts. I didn't do that yet. Okay, so there's my equation. I wrote them 2 ways. So let's find the x-intercept. X-intercept. Remember, y is equal to 0 for the x-intercept. Okay? I would probably use the equation on the right. I think it's easier. So where it crosses the x-axis, y equals 0. So 0 is equal to -2, x minus 3 squared plus 22. I'm going to move 22 over. So I have -22 is equal to -2, x minus 3. Whoops, I forgot my squared here. Squared. Divide through by -2. I have 11 is equal to x minus 3, quantity squared. Take the square root of each side. X minus 3 is equal to plus or minus radical 11. Add 3 to each side. 3 plus or minus radical 11 is equal to x. So the x-intercepts are 3 plus radical 11 and 3 minus radical 11. If you had to graph this and you didn't have a calculator, what I would do is say, okay, this, that 9, square root of 9 is 3, square root of 16 is 4, so this number is somewhere between 3 and 4, 3 point something. And so it would be 6 point something, and if you subtracted it, it would be negative point something. So you could estimate what they would be if you had to graph them. So these are my x-intercepts. My y-intercept. Remember the y-intercept. That's where x is equal to 0. Don't forget that. So I could put x equal 0 into this equation and solve it, but the fastest way would put x equals 0 here, and you can see that you get 4. So the y-intercept was 4. Find the equation of a function whose graph is a parabola with x-intercepts 1 and 4 and y-intercept -8. Okay, so I know the x-intercepts are 1 and 4, and the y-intercept is 8. So if I were doing that, I would not do it as, I would not put it in a format like that. I would put it in a factored format. We know that 1 is an x-intercept, so x minus 1 is a factor. We know 4 is an x-intercept, so x minus 4 is a factor. And we don't know how wide the parabola is, so I just put an a in front of there. So there's the general equation. But I have all these unknowns. But I was given something else. I was also given that the y-intercept is -8. So remember, y-intercept is where it crosses the y-axis, so x is equal to 0. So I know the y-intercept is the point 0, -8. So in this equation, if I plug 0 in for x, -8 in for y, I will only have one unknown. That would be a. So that's what I need to do. So there's my equation. I'm going to substitute my point in. So I have 0 for x, -8 for y. So I have 8 times a -1 times a -4. -4 times -1 is 4. So I have -8 is equal to 4a, and then divide by 4. -8 divided by 4 is -2. So therefore the equation is -2 times x minus 1 times x minus 4. Or you can multiply it out, FOIL it, and you get -2x squared plus 10x plus 8. So you take this first, FOIL it, and then multiply by -2. Example 4, find an equation of the function whose graph is a parabola with vertex 2, 0 passing through the point 1, 3. Okay, so this is a vertex. So I would use this format there because I know h and k if it's a vertex, h and k. And remember, this is a point and x, y. So now I know an x and a y. And my only unknown will be a again. So plug in the vertex. So you have y is equal to a times x minus 2, quantity squared, plus 0. So you don't really need that plus 0. Plug in your point. X is 1, y is 3, and you don't need that 0 again. 1 minus 2 is -1, squared is 1, so a is equal to 3. Therefore, my equation would be y is equal to 3 times x minus h, remember your h was 2, quantity squared, plus 0, you don't need to write. So there's my equation. For each quadratic, tell whether its graph opens up or down and intersects the x-axis in 1 point, 2 points, or no points. Remember what I said about intersecting. Second page. If the discriminant is greater than 0, 2 points, equal to 0, 1 point, less than 0, no points. So let's do that problem. So I know my A is 1, my B is -2, my C is 3. A is a positive number, so you should know which way it opens. And it opens up. And then B squared minus 4AC, B squared, so 4 minus 4 times 1 times 3. 4 minus 12, -8. -8 is less than 0, so there is no intercepts whatsoever. The second one, A is -2, B is -12, C is -18. A is a negative number, so you should be able to tell me which way it opens. And it opens down. B squared minus 4AC. B squared, here's my B, so 144 minus 4 times A is negative 2 times C is negative 18. So you have negative 144 minus 144, which is 0. So this is tangent to the axis, so there's one intercept. And then the last one, don't get confused. There's my A, negative 1. My B, there's no x-coordinate, so B is 0. C is 9. A is a negative number, so you should be able to tell me that it opens downward. And B squared, so 0 squared minus 4 times negative 1 times 9 gives me a positive number, so there are 2 intercepts. And for this one, you don't even need to find out that it's 36, you can just tell it's positive. So there are 2 x-intercepts. Without calculating, find the vertex of each parabola. I hope you can look at it and tell me 5, 4. Negative 2, negative 3. Can't look at that and tell you yet. I factored out the negative 1 so you could see. So I factored out negative 1. This is negative x squared. That right there. And there's my minus 10. So now my vertex is 0, negative 10. Okay? The zeros, if they are real, will be the x-intercepts. Okay? So that's what the zeros are. The zeros are the x-intercepts. The zeros are where y, or f of x, is equal to 0. If there's only one real 0, then the graph has one intercept. If the graph has imaginary zeros, then there are no intercepts. That's part 1.